Thank you. Good morning, everyone. I'm Dr. Su. I'm very pleased and honored to participate in the Healthy Longevity Global Innovator competition. I'm from Taiwan and serve as a director of the Swallowing Center at a university hospital. The prevalence of dysphagia is increased in Asian society, both in Taiwan and around the world, I think so. Elder individuals with stroke, Parkinson's disease, dementia, and even frailty can lead to dysphagia, resulting in choking, aspiration, pneumonia, and even death. So they need a more convenient and effective tool for assessing swallowing functions at home for daily use in order to prevent choking and aspiration pneumonia. So look at the left image. This patient has food residual outside of outside the mouth, and his tongue movement is very poor and slower, right? Making him incomplete swallowing and choking easily. And on the right side, the video fluoroscopy swallowing study in image show the food content or contrast medium abnormally enter into the trachea like this here. That is aspiration. So therefore, evaluation of tongue capability in oral cavity is the first key point and crucial. It's crucial for to swallowing evaluation. I want to sure if you hear me and see my slide.
See their slide. Yes, we can hear you and see your slide.
Okay, thank you. In Taiwan, about 1 in 10 elderly individuals experiences dysphagia. Many famous people, like our former president, had passed away due to recurrent aspiration pneumonia. This is our former president. The swallowing process is divided into the oral phase, pharyngeal phase, and the esophageal phase. The oral phase is the first checkpoint during the whole process. So how we know that the food you eat passes into esophagus correctly, smoothly, and safely. That's why an oral assessment tool that is suitable for elderly individuals to use at home for self-assessment is extremely necessary and important. Both of these clinical standard examination, one is fiber optic endoscope evaluation of swallowing, and the other one is video fluoroscopy swallowing study. These two studies are are unable to visualize or assess tongue movement function and the oral phase of the swallowing process. Besides this, there is some radiation exposure during VFS examination. The most important, neither of these examination can be used at home and need to use it at hospital and by doctors. Therefore, our amendment is a wearable device for effective real-time tool for our oral swallowing function assessment, which is also used at home and facility. That's why I'm here. Try to take a bite of food and think about it. How do you know if the bite can be chewy and swallowed to esophagus successfully? For this reason, our innovative idea is to develop a device that can assess oral phase. This device can be used in medical setting for evaluation and in home setting to provide elderly individuals with a integrated system for self-monitor their swallowing function. The left side is the medical setting and the right side is the home setting. In medical setting, we can evaluate and analysis the multi-point tongue pressure in the mouth and the delicate tongue movement degree. In the home setting, the patient could self-monitor their swallowing function at home by the device on the neck, wearing on the neck. And the data will collect in cloud via internet and connection to hospital monitor. This is our device. The entire device includes multi-point temperature sensor system and intraoral endoscope system. Yes, the first one is multi-point temperature sensor system. We measure multiple temperature against the palate. This is palate on the 3-point anterior and the middle and the posterior part. During the swallowing process, this will provide a more precise understanding of whether the pressure applied on the food and the palate is sufficient. The sufficient pressure is necessary and important for food propulsion backward into pharyngeal phase. The sensor will located at the palate with different size and length according to the gender. We designed the length range is 4.5 to 6 centimeter for male and 3 to 5 centimeter for female. The range of pressure management is up to 300 kilopascal for accuracy. We search and select a suitable material to create an oral device that provide more comfort for the elderly when they wear it. This is the intraoral scope device. This reusable fiber optic intraoral camera will be placed in the mouth to record and analyze the dynamic movement of the tongue. The table shows its specification. In the intraoral scope system will record the dynamic tongue movement in real-time model. We can see the imagery from the intraoral scope. We place the intraoral camera in different locations in the mouth to analyze the lateral movement of the mouth like this, and the upward recurring degrees with different view and angle of the camera. Furthermore, an AI model was established, which will achieve an accuracy of 96% in detecting the position of tongue tip. This is the demonstration of recording the maximal lateral distance of the tongue and the maximal turning degrees of the tongue. Okay, currently, all available competitive products that analyze the intraoral parameter can only measure single-point tongue pressure and do not have the capability to assess tongue movement. Additionally, they are very expensive, about $6,000 to $10,000. This will cause a limitation for their use for assessing oral function in the for the elder people at home use. After then, we are going to do clinical trial study in National Cheng University Hospital. We will enroll about 45 dysphagia patients, including Parkinson's disease, like with very severity, and 15 participants in motor normal control group. Participants will perform a water test with wearing our innovative device. Their tongue movement data and the multi-point temperature data will be recorded. By the way, a patient who had difficulty in open mouth will be excluded. This is the example of the clinical study. The participant will place the device in oral cavity with drinking water at the same time, and the process is under the comparison with VFS examination. After after the water test, we will collect data including a multi-point time pressure like this, and the time movement capability like this, and merge the data to AI model and analysis. The data will show the dysphagia risk is the document. Here, we now have completed the design and the development of the enter device and create a prototype. We are going to prepare a clinical test soon. In summary, our swallowing team had completed a device prototype for our swallowing function or swallowing function assessment, and then we'll perform clinical trial with water test in dysphagic case. This clinical data will support the establishment of AI model and a cloud database. The cloud database can not only for remote medical monitor and also the future scientific research. Through this innovative designs and integrated system, we hope to create a safer safety network for aging community. We hope every people or every elder individuals check with care and eat without fear. Finally, we hope that this device can provide a safer, more accurate, and more reassuring swallowing function assessment and monitoring system for an aging society, reducing the incidence of fatal expiratory pneumonia. That concludes my presentation. Thank you very much. This is our team. The left side is the medical team, and the right side is our engineer team. Thank you very much.